All right, let's get right into it. Today, we're going to tackle one of the biggest, most important questions of our time. What energy source is actually going to power our future?
I mean, this is a huge question, right? And you hear passionate arguments coming from every single direction. So to even begin to figure this out, we've got to go back to square one. We need to understand what we're really talking about. Okay, let's dive in.
So before we can even think about picking a winner in this whole energy race, we really need to understand the fundamental rules of the game. So let's start with a quick Energy 101.
At its core, energy is just what makes things happen. It's the juice that heats our homes, gets our cars moving, and lights up our screens. Seriously, without it, nothing goes. But, and this is a big one, to really get a grip on this debate, we first have to untangle something that trips a lot of people up, the difference between energy and its close cousin, power. The easiest way to think about this, imagine you're on a road trip. Power is like your speedometer. It's how fast you're going right now. But energy, that's your odometer. It's the total distance you've actually covered. See, you need power to hit the gas, but it's the energy that actually gets you from point A to point B. Here's another super important piece of the puzzle. The energy we actually use isn't what we find just lying around in nature. Think of it like baking a cake. We start with our primary energy. Those are the raw ingredients, stuff like coal, sunlight, or crude oil. Then comes the conversion step. That's the baking that happens inside a power plant. And what comes out of the oven is the secondary energy, the finished cake, which is the electricity or gasoline we can actually use. And here's the key. Just like baking, the process isn't perfectly efficient. Some energy is always lost along the way, usually as heat.
Okay, with the basics down, let's meet our first major player in this energy showdown. We're talking about the old guard, the sources that have been running the world for over a century, the reigning champs, fossil fuels.
And wow, just take a look at this. It is absolutely not an exaggeration to say our entire civilization runs on fossil fuels. This chart says it all. A whopping 87% of all the primary energy the world uses, it comes from them. That is a massive slice of the pie.
And when we say fossil fuels, we're mostly talking about these three. They are woven into every single part of our modern lives, from powering massive factories all the way down to the simple act of cooking dinner. But all of this incredible utility, well, it comes at a pretty steep price. See, burning these fuels releases carbon dioxide into the atmosphere. And the simplest way to picture what that does is to think of the Earth wrapped in a blanket. Now, a thin blanket is good. It traps just enough heat to keep the planet livable. But by adding more and more CO2, it's like we keep throwing a thicker and thicker blanket on year after year. And that's what leads to global warming. Okay, so if the old guard is so problematic, what's next? Well, let's look at one of the most powerful and, yeah, probably one of the most controversial alternatives out there, nuclear energy. Now, the way this works is surprisingly straightforward in concept, even if the physics behind it is, complex. It's all about making heat. In a process called fission, you split tiny uranium atoms, which releases a tremendous amount of heat. That heat boils water, creating high-pressure steam that spins a turbine, which then drives a generator to make electricity. At the end of the day, it's basically just a super high-tech steam engine. And the amount of power you get from this process is just unbelievable. It's all thanks to something called energy density. Get this, a single gram of uranium, that's about the weight of a paperclip, releases the same amount of energy as burning nearly 3 tons of coal. That incredible density is exactly what makes nuclear such a compelling option. But, of course, there's a catch. On the one hand, you get a massive amount of reliable 24/7 power with zero carbon emissions. Awesome. On the other hand, you're left with radioactive waste that stays dangerous for thousands of years, and the public's concern over safety is a huge hurdle. It's the classic high-risk, high-reward scenario. All right, let's shift gears and turn to the contenders that are often seen as our best hope for a sustainable future, the renewables. The key advantage of this clean energy team is right there in the name. They are renewable. They draw from natural processes that are constantly being replenished, whether it's the sun shining, the wind blowing, or water flowing downhill. A hydroelectric dam is a perfect example of this energy conversion in action. You start with the stored or potential energy of all that water held back in the reservoir. As it flows down, that energy converts to kinetic or motion energy. This spins a turbine, creating mechanical energy, which finally powers a generator to produce electricity. It's a really elegant transformation, from a simple raindrop all the way to the light in your home. So they sound perfect, right? Clean energy, free fuel,
endlessly available. But there's one major fundamental challenge that they all have to face.
And here it is, reliability. Unlike a coal or nuclear plant that can run around the clock, most renewables only work when nature decides to cooperate. When the sun goes down or the wind just dies, the power generation stops. This on-again, off-again nature is called intermittency, and it's the central puzzle we have to solve if we ever want to rely on renewables for all of our power.
So now we've met all the contenders. It's time to put them side by side and see how they really stack up in a final comparison.
This table cuts right to the heart of our energy dilemma. You can see the fundamental trade-off right here. Do you want perfectly reliable, on-demand power? Fossil fuels and nuclear deliver that, but they come with some pretty significant environmental baggage. You want perfectly clean energy? Renewables are the answer, but then you have to solve that reliability problem. There is no perfect, easy choice here. So, after all that, what are the crucial points to remember? Okay, first, energy isn't created, it's just converted, and that process is never 100% efficient. Second, our modern world is built on fossil fuels, but the bill for their environmental impact is coming due. And finally, the choice for our future really boils down to this. Do we manage the risks of reliable power, or do we solve the puzzle of clean but inconsistent energy?
And now, after seeing all the evidence laid out, the question goes to you. There's no single right answer here, just a really complex set of trade-offs. What do you believe is the right path forward? We'd love to hear your thoughts. Is it a mix of all of them? A massive bet on a single technology? Join the conversation and let's discuss it in the comments below.